Hello everyone, welcome to this release review of Creator 2.4.1. My name is Stefan Schulz. I'm the Conformiq Chief Technical Officer and also product owner from Conformiq Creator, and I will be presenting you this short update. Okay, Creator 2.4.1 was released last week. This is a Conformiq patch release, so it is not a major release in the sense that it brings major new features, but focuses mainly on usability aspects. It is coming now about 6 weeks after our 2.4.0 release, and these following things have been addressed, and I will be demoing them. So, on the modeling side, we have enhanced the problem view, which is at the bottom of the Conformiq modeling perspective, with message categories. And then we've had some changes in the test generation options, and including also around combinatorial data that I would like to point out. And probably the most emphasis today I will spend on actually talking about the reverse engineering solutions that has been changed. Okay, starting on the modeling. The modeling problems here has been improved in terms of that there's been a so-called Conformiq category added, which actually allows you to view the messages in that view much more conveniently. They're grouped according to categories. So here's some examples: activity diagram model, structural diagram modeling errors, incomplete modeling, but also things even like computational complexity as they appear. In addition to that, what I will show you is that we have now a new category for potential modeling problems. I will show you how that works. And finally, there's also a new category for modeling best practice, which is intended to guide you on the right path as you're using Conformiq Creator. So going to the demo, I'm going to use this basic example, which is the Conformiq web application, which is something that everyone here probably knows. So what we see here already is an informational message, which is that, for example, this currently selected project has no layout information, and that we can fix by using the quick fix. But what I want to show, for example, if I have an incomplete diagram, so let's say I remove the successful node, what I will see happening here now is I will have two categories pop up. One is called incomplete modeling, which is advising me that I should complete the drawing of the decision node, and another one is a general error which appears because I am now having a final node which is required to have in the diagram. So if I do this change, then I get this node back, and these warnings disappear. This new category here is also informational, which is information for background information that may or may not be required to react upon. Then let me demonstrate to you one change where we have been improving, so to say, the error finding. So for example, I have here in my valid user decision box, I'm checking if Stefan is logging in ABC, and if I, for example, now specify here a constraint where I select the value. And then actually what I'm going to say now is that I will exactly enter this value and save my model. Now, in previous versions, there would be no additional warning. Now we have actually a warning here which is telling me that this may be an issue in your modeling, but whenever you're constraining your input in this way or manner, then we cannot, for example, here now cover the the outgoing branch. In some modeling situations this may be okay, but in many it's also unintended behavior that is coming out. So you have now a bit more information as to why something is, that some things are potentially uncoverable, and there is a reason for it. Similarly, the final thing I wanted to show is also that modeling best practice. One example I can show here is that, for example, in this model, if I delete all of the requirements, I'm actually going to get here a new category which says that model contains no requirements, which is a modeling best practice that when we test models for test generation, that we have at least one requirement that is covered. So if there's absolutely no requirements in the model, please get used to seeing this advised to actually add requirements to the model. Actually, we also have a check in there that if you have too many requirements, so our guidelines say about 100 requirements per project is something that you should be modeling with, then you will get similarly here an informational message saying like, you have too many requirements covered in your project, please consider how to refactor your model. So these are the, this is the advances here on the problems view. Please note, I don't know if you've noticed that if you click on that triangle here, you can actually select how you group by it. So if you click on severity, that was our previous default, then you again see how all the informations are inlined. If, however, you group back by Conformiq problem type, which is the new default, then you actually get here these categories. So much about the modeling. Let me come back to my slides. So this is what we have done here. I think this will help you in faster finding out what's wrong with your model, or helping you to create better models. The second things are things related to test generation. We have done some minor changes in moving some options that used to be in the main tab of the Conformiq options into the advanced tab. And finally, also, we have been deprecating data coverage, and I will show what that actually means. And lastly, but not leastly, we have also actually been able to put some further performance improvements into the test generation when you're using time limits for test generation, which is the new default. So when I go back to my model, I have here now again my simple web application. And okay, let's put this requirement back in. So now, okay, let me also fix my login model here by making that, I'm setting this condition back to don't care. Now I'm getting rid of my modeling problem, fine. Okay, so now here I have, let's say, I take this fill form place. So here's the point where I enter data to the web application and I see if it's a correct data. So if I now go in here and I provide some sample values, so CQ001, and then I want to enter CQ002, and then I want to enter this 1 time or 2 times. So the way how we have been dealing with this in the past, okay, 5 times, was that we have been using this data coverage settings where we have been, for example, saying here, I want to now generate tests going through all of the combinations. As we will see now, this is what means is deprecated. So we have a new warning popping up that which advises that you should not be using this option anymore. The reason for this is that in the past release, in 2.4.0, we have actually implemented a better way of implementing this, which is the combinatorial action, which we advise to use to model this type of scenarios when you use combinatorial data, because it's more flexible. This is limited to this single input only, but with a combinatorial action, you can actually express even the combination of data between different actions. The nice thing is that, as you can see on this warning, there's also a quick fix. So if you go back to the quick fix, it will offer you to actually remodel this for you. And what you will see in a moment here is that you have here now your combinatorial action, which is predefined exactly in the same way as before. And as you can see, the data coverage is now set to default, meaning we are not using this option. So this is what the deprecated means. Deprecated means you can still use this action, you can still generate tests, it's still valid, but it's just not a way of modeling that we recommend using. And instead, again, we want you to use these combinatorial action. When we get to the test generation options, this is in the Conformiq options. This is, again, also should be a familiar dialog. So what has happened is that we've moved some options which we consider advanced test generation options to the advanced tab. So basically, we have been putting here enable only finalized runs as well as maximum look-ahead depth setting, which is 2 options which we believe you should only use once you have some experience with the tool and you understand what the impact of using these options is. Please also notice that, for example, when you enable finalized runs on a project, then you have, for example, here a warning pop-up that says, like, you notice that you have finalized runs on this may have impact on the test generation. By the way, all of these things that I've just been describing here, they're also available in a document you can download from a website which is called Deployment Guidelines for Conformiq Creator. Okay, so this brings me already to the last part of this introduction of 2.4.1, which is integration features. So here we have the following items which come with the 2.4.1 release. For one, we have been spending quite a bunch of effort in bringing our reverse engineering solution into a status that whatever test suite we import, there will be always a model created from which you can generate tests. In the past, there have been certain conditions where this was not necessarily possible. Now this has been basically eliminated, and we're able to faithfully produce the tests that were used to feed in to the tool one-to-one. And then also we have done a lot of simplification to the import of manual tests from Excel. We'll demonstrate that. And then there's two new types of importers which can be actually used to speed up the modeling of structure diagrams. So I advise you to take a look at these. At this moment here, part of the release, we have imported to create basically graphical user interfaces based on an Excel file specification, and the same we have for mainframe interfaces. I will demo those, but please note also that already we have some first prototypes for specifying in the same way mobile interfaces as well as embedded interfaces. So let me just show here in the demo these importers. So, by the way, again, I want to remind you, if you have any questions, please use the Q&A feature to ask your questions so I can go through these questions in the last 5 minutes. We have here the manual tests, for example. So let me just go to this project and import the manual tests. So basically here we have the standard importer as we have had it also in previous versions. And now the interesting part here is that once you select the file that you import, basically you can select here the row, and based on that it will automatically try to find the column names that map to the corresponding test information. In the previous versions of the Excel importer, this information had to be specified using column numbers. So now it's the names, and of course here, as you can see, you can also, it gives you basically now a drop-down list for all the column names specified in the header row, and you can even select and modify yourself which ones are to be selected. Then we have the parameter indicators are configurable now as well. By default, they're actually $signs. For this example, they're actually the double quotes. And then we have here also an ability to actually limit the import of test cases. So, for example, as we have now seen that people have been trying to import significant amount of test cases all into one project. Again, we have this kind of round number of 100, which we advise to use as the absolute maximum to construct a model. If you want to increase that, you can increase that limit, but models reach a certain amount of complexity that we would advise you rather to break up that file into multiple Excel files with tests which are less than 100 tests, and then to import those. The rest is all the same, more or less. We import and optimize the model, but let me just show you here this new feature. In order to retain the test cases now, what we have actually created is that test cases generated from the model, they will be actually getting name tags after the name that was actually used in the test suite imported. So these are the names from the test from the Excel sheet. And then again, there is various places where we actually ensure that this data is, so basically the tool here generates an artificial concept of an existing test as it was which is the old test cases generated that you have been importing. And this knowledge is used to take decisions and traverse from event nodes exactly in the same way as it has been before, and also, for example, to handle the input of data according to the tests as they were read in. So if, for example, you don't want to have this information, basically you can remove this action which injects the tests and then update your model accordingly to have it basically been independent of the test suite as it has been imported. And the rest here continues again as same. So then we can go to the Conformiq test design perspective. Let me just check my options here. Okay, I have finalized runs on. This is good. So okay, I have already tests in this project. Let me just delete them. So basically here we are now going through the imported model, generating tests from them, which is supposed to give us exactly the same tests back as we have imported. And once the test generation finishes here in a moment, we can then yes, so now the model is loaded. Now we're going into the test generation. Test generation is done. We have imported 3 tests, and then we can see here in our review phase as to how they were extracted. Okay, this is the reverse engineering. So please understand that this handling or exact reproduction of test cases as imported from the model is not just specific to the Excel import, it also applies to our ALM test plan import, to our ALM BPT test import. It applies similarly to our Gherkin importer. So all of these importers that take in traces, they now generate this extra information about the test that they were actually coming from. And this again is to warranty that we get exactly the same tests out as put in. Okay, finally, the final thing I want to present is maybe I use this graphical import. So we have now a new importer here. So maybe here I should really spend some time to talk about the Excel part of this. So the import assumes that we actually use a template for specifying the user interface here that follows these standards, so that, for example, I have a GUI object sheet which has an application name column, screen name column, field type, and then any number of field names. So here basically the user has specified I have a login screen with 2 text boxes and this button, right? And then I have similarly a main screen which has 2 text boxes, different types of text boxes, and a label. And based on this information, basically we will construct the model. So this is the source file that we have that we can read in. And this is the file that I have here. And then if I go to the import, I select import graphical user interface from Excel. Then I go back to my project, I select the file, and now basically here I have an option. By default that's not checked, so I can also import it as an ASD library. We advise to use this, which is the structure diagram library. Especially when we are working with automation, it's always helpful to use structure diagram libraries. And then what we get out of this is this model. I can lay that out, this diagram, and as we notice, the layout algorithm as before only pertains to the objects but not to the fields themselves. But with a little bit of creative work I can get the rest out here. But the point is, I've basically now here saved the time to draw these diagrams by simply putting them out. Please notice some of this Excel-based specification is for a subset of the elements that you can draw manually in a structure diagram library. So it's more or less like a quick start for your diagram drawing. And basically now, I can just go off and say I want to create a new activity diagram. and start specifying my behavior. So this basically can help us to just reduce like the time that we spend in specifying structure diagrams. So basically here I have an activity, and here then I can just start using the actions. So maybe first I check, is our login screen specified? Fine. Then I go in and I say, in my login, I want to fill out the form, and then I want to click the button to log in. Okay, so I haven't spent a lot of time in specifying this here, and so it's pretty fast now to generate all the SD diagrams and then get them to use. Again, the limitations you should be aware of. Again, all the fields that you put, it creates one single form for your entire screen. We have not yet supported more, let's say, having multiple forms per screen. The idea is to keep the Excel very simple. So basically here you can see also the choices in the object types. Here is that we can model hyperlinks, text boxes, button labels, calendar. Basically the most essential widgets where we see people use 80% of the time, they can be put into one single sheet allowed and enumerated here. The allowed values sheet is for drop-down and radio buttons, and again, they only have to be filled in these cases. So this was the graphical interface import, so that was that. Similarly, we have here the final and last piece, which is the mainframe application. So this is a slightly different Excel format as before, shown for the GUI. So these Excel importers all have their own specific Excel format. So here, basically, this is the same, that we have application name and screen name. But then actually, when we interact with mainframes, we have found out based on a customer project that the people are mainly using these three functions on each screen. They either input data, they search for certain using certain fields on the mainframe, and they validate that the screen has certain output. So here again, basically in one row we can specify the whole screen. We specify all the fields that I want to actually enter kind of data to, and then I can have here a field that I want to perform a search on. This can, by the way, if you want to insert multiple rows, you can do that easily by simply copying, insert copied cells, and then basically you have here now the ability to list at most 3 fields. And then again, by default, these are string fields. You can use this hash notation in order to kind of say this should be actually a number entry or Boolean field. In this application, I've just left this SKU is a string field and the others are numbers. So once I specify it in this way, I then can save it. And now here, go to the import mainframe interface from Excel. Again, I select file, which is in my project. Okay, and for these type of interface, we recommend to leave this option always checked. So here now we actually generate a SD library, and the SD library is more or less the same like in a regular structure diagram. The only thing is that it cannot be modified. It is basically a read-only structure diagram. As you have seen, there's also an option to not generate it this way, but we recommend to always generate it this way because these functions that are generated are delicate, and so yes. Again, if you want to then create your activity diagram, you can start the same way I've just shown you before by drawing your activity diagram, and you have spent no time in structure diagram creation. And I can go through here, and then I can say I want to start by searching my SKU field, and then I want to say what fields, what is it that I want to search for, and I say I want to search for my product. And oops, I'm sorry, that was clicking on the wrong thing. And basically here we go, and we can start generating tests. So that basically completes the overview. So again, in summary, the Excel import or reverse engineering from tests has been improved by being able to completely and faithfully reproduce the imported test. And then we have this new kind of series of Excel-based importers. Right now, the graphical user face importer and mainframe interface importer, which allow you to basically speed up a lot the interface specification, and let's maybe focus a bit more on the activity diagram creation as part of the modeling process.